So today I'm going to be talking about delivering a database as a service using advanced AWS networking. But really, I'll be taking kind of what we do as a company, but kind of generalizing a lot of the lessons that we've learnt, and then hoping that you guys can apply them and take them if you need to deliver your own network services yourselves. So my name is Ben Bromhead. I'm CTO and founder of Instacluster. Instacluster, we provide Cassandra as a service. We currently manage, that number's actually a little bit out of date. We now manage just over 350 instances, with 95% of that on Amazon Web Services. So first of all, I'm going to talk a little bit about some of the challenges faced in delivering a database as a service. And again, as I mentioned previously, I'll be using Cassandra as an example, but really you could take this and apply this to any service that you need to deliver within your organization or externally to third parties. And then I'm going to talk a little bit as well about how and when to use various AWS networking features to solve some of the challenges that you will face in terms of delivering these services into your own organization. And it'll also include a bit of a meandering history of our own AWS journey that's kind of weaved in there. So first of all, I'll just quickly cover some basics. What is Cassandra for those that haven't heard of it? It's a scalable, highly available transactional database, so it's something that you run your main application on, inspired by Dynamo and big table papers. So it takes the Dynamo masterless architecture and kind of merges it with the big table wide column storage format. It includes tunable consistency, so that means that you as a developer you can make a choice between whether you want an operation that you're about to perform to be either highly consistent or highly available, depending on the number of replicas that are available. And one other thing that'll kind of be a little bit important as I'm talking about some of the decisions we made, is that clients are very much aware of the topology of the cluster that you're supporting. So what should a Cassandra as a service actually look like? It should be high throughput, it should be low latency, it should be secure, it should be easy. And unfortunately, this bullet point fell off, but it's actually one of the most important things. It should be highly available. So when we started off down the path of designing and building out Cassandra as a service, one of the challenges that we faced, or one of the challenges that anyone who provides something as a service will face, is multi-tenancy. So how do you split up the service that you're providing and provide decent isolation to the customers that you're working with? So how we first started, or our first attempt at multi-tenancy, multi-tenancy was actually done by deploying resources under our customers' own AWS accounts. And we had limited access to those accounts for our IAM users, and billing was done via Amazon DevPay. So the reason why we decided to go down this path is it allowed us to provide isolation kind of at the network and the account level. We explored a few other things like doing multi-tenancy using Cassandra itself, or doing multi-tenancy using containerization, although this was a few years ago, and so we're looking at doing it with Solaris zones. But I guess you got to look at what Cassandra is. It's essentially it's a scalable database that's designed for when you've got more data than what will fit into a single server. So trying to actually do multi-tenancy within a single box tends to not make a lot of sense, particularly given the use case that Cassandra is for. Plus, there was a few issues just with the way that Cassandra handled certain things that just we would have to kind of rewrite a lot of stuff within it to do true multi-tenancy within the project itself. So, as I mentioned, there's no point trying to multi-tenant Cassandra, and that's kind of why we went down, doing it within the AWS account. This is what it looked like from a network diagram level. This was also before we started to support VPCs. So this is all kind of EC2 classic. What we've got is, would automatically split things across different availability zones, would provision and configure Cassandra, make it do its thing, and then isolate it all using a security group. Now, of course, because this was in EC2 Classic, it also you shared the private address space with all the other AWS customers, and then would also provision elastic IPs with each instance as well to support multi-region connectivity. It had a few issues. One of the main ones was we were now holding the keys to people's AWS accounts. It made a lot of things very easy for us, but it also gave me cold sweats at night because I didn't want to have the keys to their kingdom. Now, we provided IAM templates that would, they could apply to the IAM user that would restrict the permissions that they gave to us. But more often than not, they just actually kind of gave an allow all rule at the end, and we could kind of do anything in their account, and that was not particularly good. It was very simple to run. It was just a matter of loading a new set of IAM credentials whenever we went to do stuff. Billing was very simple due to Amazon DevPay, but there were some real issues that we faced. I'll talk a little bit about VPC later, but when you're working with different AWS accounts, one of the things to keep in mind is that actually no two AWS accounts are actually the same, particularly when you've been you're dealing with people that have had AWS accounts for a few years, and then you're also dealing with people that have recently signed up. So a great example of this is we actually hit a few issues where the users would not have certain services enabled if they were old account users. I don't think Amazon has done this for a little while, but previously, some of the new features, they were actually opt-in. So you'd have to log into your AWS console and enable something like simple DB or all that kind of thing. So it made it very hard for us to provide a very smooth process because, first of all, there wasn't any API that we could call to say, hey, enable this account. And so for some people's AWS accounts, it would work. For others, it wouldn't. Billing wasn't quite as flexible with using Amazon DevPay simply because it was just a fixed rate that you charge the hourly AMI at. So we decided to kind of move away from that. The other really annoying thing is that because it was provisioned under their account, customers would also then mess with the resources that we provisioned. They'd turn stuff off, they would change security group rules, and it was very hard to kind of keep our management service in sync with what actually happened under AWS. The other really interesting thing was it's actually really hard to detect availability zone capacity before you go to launch an instance. The reason, and I guess going back a step, one of the reasons why we had to detect which availability zones had capacity is that under my AWS account, US East 1A is actually different to your US East 1A. I can guarantee you it's not going to be within the same data center or the same availability zone. So each mapping is actually different on a per account level. Then we had to detect which availability zones we had access to. And then even if the API said, hey, yep, you're allowed to deploy in here, there would be some instance type families that we still couldn't necessarily deploy if that zone was constrained. So there'd be some zones where AWS would report that it's constrained on, say, the M1 series or the T series. So we kind of had to do some funky things where we'd quickly try and launch an instance in an account, then delete it before it provisioned to try and work out whether we had capacity there when loading in someone's new AWS account. So as you can see here, multi-tenancy by AWS account, it was very simple for us to get up and running and start providing services into our customers' accounts, but there was a lot of overhead that made it very fiddly, and we kind of, especially with the fact that it was all EC2 Classic based and we wanted to start supporting VPCs, it was all a bit of a catalyst to change. So we decided to run everything under our own AWS account and provide services into our customer that way. The pros with this is it greatly reduced our support overhead. People couldn't mess with the resources that we were provisioning under their account. We were able to take control of billing, and it really allowed us to leverage some of the cool features like reserved instances and all that kind of fun stuff. And it really simplified our own interface with AWS. The cons, we had to rewrite everything, but like with all good IT projects, you're going to do that anyway. We had to do our own billing, but also when we decided to do this, some of the easy developer API ecosystem had kind of sprung up in the meantime, and it was actually a little bit simpler than we thought. We already know our own availability zone capacity. It does mean that we have to then manage it, and we are in a situation where we do have some zones that we are now constrained in. But that's something I'll talk a little bit about later on. And as we use this opportunity to move across to using VPCs, it then presented us with the challenge of how do we allow our customers to connect to the service we provide via a private interface and not having to go out over a public IP address. So how do we do this in a VPC? Because a VPC inherently stops you from doing that compared to EC2 Classic. So this is what it looked like. The way we decided to go down this path is that for each customer in each Cassandra cluster, we would actually provision it in its own VPC. So each customer would get its own isolated Cassandra cluster. Even if you had multiple clusters within the same customer account, they would be in their own individual VPCs. That allowed us to kind of really isolate things at the network level, and that's how we started to solve some of our own multi-tenancy issues. So the side effects include we now have a lot of VPCs. We're actually getting to a point where there are actual hard limits on the number of VPCs you can have per account. So we're now having to run multiple AWS accounts just to get around that VPC limit. So we're almost kind of like stepping back to where we came from, but at least they're all owned and managed by us. So in terms of how can you take what I've just talked about and apply it to a situation that you're potentially looking to have to support. If you're going to be delivering a service into your own organization or to third parties, when is it a good idea to multi-tenant with VPCs? So primarily the service that you're providing, it needs to be a network service. It needs to be something that it should be something that people are just going to connect with to on port 9000 or whatever it is, and that's the main way they consume it. It's got its own protocol, its own API that you don't want to say stick a HTTP front end in front of or that kind of thing. The other thing that we find it very helpful for is when the service you provide is directly related to resource consumption. So again, if you're providing databases as a service, you tend to be charging your customers or billing back to your other departments based on the resources that they're consuming. So this isolation level makes it very simple. Using some great AWS features such as tagging and all that fun stuff is very easy to then tag which resources and get some good billing metrics out of the back of that. The service you also deploy leverages a complex network configuration. So by isolating things within a VPC, it lets you do some really cool things like all you need to do is be able to provide network connectivity in, and then someone can consume that service. So you don't have to worry about, if we drop a VPN into that VPC, we don't have to worry about then configuring firewall rules to stop it talking to other customers. We just need to provide network access, and then they consume it as they see fit. And this brings me on to the next challenge that we faced, is connectivity, right? So as I mentioned before, it was great to go down the VPC route. We got access to enhanced networking instances, all sorts of great stuff. The network's a lot more stable in a VPC environment. And it simplified our multi-tenancy issues. But it came at the cost of how do we figure out supporting connectivity, particularly from external customers. So how do we support people connecting in from different service providers? How do we support developers simply connecting in from their own private or personal machines? How do we support things like multi-region Cassandra clusters where they actually do need to communicate over different continents and that kind of thing? As well as hybrid clusters, so ones that there's a portion running in a cloud environment like AWS, and then also within a private data center. So, the resulting requirement from all that is essentially, how do we let people connect in from outside AWS? Luckily, Cassandra's really good at this. Thanks to some great work by Netflix, it actually natively understands NATed environments. So that's where you have a public IP address that is then translated into a private IP address. So Cassandra understands that, and it can say broadcast its public IP address is the main contact point, but it can still do all its communication over its private IP. So what that means for us is we can deploy instances into a subnet with its, within the VPC with its own internet gateway. We then give a public IP address for every node. You sprinkle in a little bit of security group magic and Cassandra authentication to kind of make sure it's all protected. And you've kind of got something running in a VPC that's very similar to what you were doing with Cassandra and EC2 Classic. Problem solved, right? Here's a very simple diagram of what something running with elastic IPs look like. And when would I want to do this? When you want people to actually use your service externally. So the next challenge we faced in providing access into our own service that we were delivering is to support Heroku customers. So for those of you who are not familiar with it, Heroku is a platform as a service that runs on top of AWS. It allows you to run clients, and Heroku takes care of a lot of the management in terms of scaling and running it and coping with load. The one issue that we had with it is that people connecting from Heroku actually have no control over the IP address that they're connecting from, right? So the unit of work within Heroku is called a dyno, and each dyno will periodically get refreshed at least or at a minimum of once every 24 hours, I believe. So that means that the IP address of the clients that they're connecting from changes quite often. So it's something very hard to kind of manage from a security group point of view. One, because at the time we didn't have an API that let you do that automatically, but two, updating security group rules frequently, particularly in a system where it's high throughput network, can be a little bit painful, because when you update a security group, there's actually a small fraction of time where it cuts all the links, all the sessions, and then reapplies the rules, and then all the network comes back up. So you kind of get this little blip of network stuff not happening. So it can be a little bit painful. So the resulting requirement we had from this was actually to support secure global ingress, which is a fancy way of saying the firewall needed to allow all. So this is an example of what it would look like if a Heroku customer was trying to connect. There's the various dynos running in Heroku. They can all connect at the moment. But then, of course, one of the dynos cycles, and you're out of luck. So what we did is we allowed the ability for people to kind of tick the allow all box in the security group. This is just adding 0.0.0/0. But the really great thing is that Cassandra actually supports client-to-node certificate authentication, as well as the other traditional database authentication methods that you're used to, such as username and password. So we rolled out support for certificate authentication, and it really gave that security or that confidence that people could be running a database service that is exposed to the big bad internet. And so it all just kind of works. So when you need to support universal ingress, it usually tends to be when your customers are unlikely to have a static IP. You're supporting complex or changing access patterns where your customer or the department you're supporting has no control over these kind of things. But primarily, you only want to do this when your service can support robust authentication. If the service that you're providing doesn't necessarily do it, you can do things with like S-Tunnel, which will provide SSL authentication on top of just a plain text network service. There's lots of different things you can do there. However, some customers think that accessing their database over a private IP address is scary. And I don't blame them. Like you talk to any traditional admin and say, hey, I want to let this database be accessible by everyone, and they'll flip out. And when you look at the way that we quite often structure applications, is that, depending on whether it's like a 3-tier architecture or microservices or what have you, is that not all applications will actually have direct internet access, so they won't be able to necessarily directly access a public IP address. So it was easy to do with EC2 Classic because when working with other AWS customers, we all shared the same private IP address space, and it was just simply changing some firewall rules. But now that we're running in a VPC, it's a bit harder. So the requirement that we had was really, how do we provide access to Cassandra via private IP, or to extend that, how do we just provide private access? This could have actually been really impossible with a VPC if it wasn't for one key AWS feature, and that's VPC peering. VPC peering had saved our lives in terms of delivering services within an AWS environment. It also has dramatically saved some of our bandwidth costs as well, because as soon as you're connecting via a VPC peering connection, you're then only paying cross AZ rates. When we first did this, I believe, now someone's probably going to shout out and correct me if I'm wrong here, but at the time when you did connect to a public IP, that was charged at the public IP rates. I believe that's now different. But someone feel free to correct me if I'm wrong here. So this is what VPC peering looks like. On the left-hand side, we've got everything managed by our account. We've got some VPCs sitting on there. And what you can do is you can actually set up VPC peering connections with third-party AWS accounts. So it's simply just a matter of you providing giving us your AWS account number, the VPC ID that you want to peer with, and also the network subnet that VPC is running on. And we can automatically create a VPC peering request that you then accept. And we then update our own routing tables so that we know how to talk, update the security group rules, and then all of a sudden, we've essentially got native communication between the two VPCs. The other interesting thing about VPC peering is that on both sides of that, everything it sits within your own security group. So that's been really beneficial for some of our customers that we've dealt with, because when we've suggested VPC peering, they've gone, wait, well, you want to have access into our VPC. But the really good thing with security groups is you can allow just simple outbound access from their instances. They connect to the Cassandra cluster running by us, but they actually don't have to give us any security group permissions to connect back into their services, because the security group system supports tracking stateful connections. So they're protected by their own security group. We can't see any of the resources that are within their VPC other than what's connecting back to our cluster. So VPC peering is our most used AWS feature, other than EC2 instances, which we run everything on, and VPCs. 70% of our production clusters have one or more VPC peering connections with another account, and has been absolutely critical to adoption within the enterprise. It's also critical for multi-level architectures where the app layer does not have external egress, so it can't talk to the internet. We still almost always need to educate our own customers and the consumers of this service about VPC peering. It tends to be a fairly little known feature, particularly when a lot of the customers that we at least work with, they're still just all running in a single VPC. You still incur into AZ traffic charges, but that tends to happen anyway just by the distributed nature of Cassandra. So when do you actually want to use VPC peering? Obviously, it's when resources that are accessing your service are located in AWS, and you provide a service that tends to be used by a tier that is not able to communicate externally. And then you've also, when you've got security concerns around that. So taking that away and applying it to a situation where you have to deliver services internally to your own organization, VPC peering will be your friend. In terms of network performance, it's like being on the same, within the same availability, within the same VPC, you'll obviously have the same cross-AZ latency that you get, but it's been super helpful for us. So challenge number 3 that we face with doing this is invariably when you build any kind of as-a-service business, the way you're going to make money is by ensuring the uniformity of customer accounts. And if you're delivering services within your own organization, the way that you reduce your own support overheads is by ensuring that there is uniformity of the service that you're delivering into the organization. It reduces support costs, ensures consistent experience across customers. That's actually a really big thing. And as a growing startup, one-off solutions actually still really haunt us because we've had to do things to try and win business and all that fun stuff. But as I mentioned, one-off solutions have also won us accounts, and eventually they've been rolled into production features. So whenever we go to eat the forbidden fruit of doing one-off custom solutions, is we always try to leverage AWS components, kind of the off-the-shelf components for one-off solutions within our customers' VPCs. This is primarily enabled by the fact that we use VPC as our multi-tenancy approach. It means that anything that we do within a single VPC, it's not going to impact any of our other customers. And so by grabbing some of the AWS components and dropping them in there, it's kind of always a proven and managed solution. And it also means that it's very easy to kind of bring into the fold once we start to support it officially. A good example of that is, let's say a customer wants to access the underlying Cassandra data file. So the way that we do backups is we just snapshot the directory that it writes everything to, upload it into S3. So we already are backing stuff up to S3. We didn't really want to write a whole UI on our website to provide customer access to the snapshots. We didn't want to have a service that would then stream it and all that kind of fun stuff. What we now do is we actually just provide a read-only IAM credentials to the S3 bucket containing that snapshot and say, have fun, download it as you will. So that's something that we've been able to do in a custom solution that is now being kind of rolled out to the rest of our production systems. A second example, and this is probably the best one because it really illustrates the usefulness of multi-tenanting by using VPCs and also showing how you can isolate custom solutions or one-off solutions to a given customer. So let's say we have a customer, they want to migrate their existing on-premise service onto AWS, onto our own service. They've got no public IP access within their cluster. It's within their own private data center. So we can't just set up public IP, multi-region cluster like we would normally do. What we actually ended up doing was we used AWS's virtual private gateway to connect to their VPN concentrator. Once we did that, we then had direct network access into their private data center. We could join the cluster, we could join the instances that we were managing to their cluster as a second Cassandra data center, let Cassandra do its thing and sync the data across. And once we'd done that, we kind of just cut the link and we'd move them across to our service without any downtime. But in terms of delivering custom solutions, that was the first time we'd ever touched a VPN in terms of delivering our service. In fact, we tend to be fairly against using VPNs as permanent solutions to providing connectivity because, even with redundant links and all that fun stuff, they tend to be fairly flaky. They have a real overhead on the throughput that you get, and it tends to be an awful single point of failure. But we were really able to grab what AWS provided in terms of their own VPN infrastructure, drop it in for a one-off solution, and then use that to migrate the customer across. So I guess the key takeaways that I really want you guys to come back from this is using a VPC per service really simplifies your multi-tenancy options. You do have an overhead of having to manage the VPCs themselves, but Amazon provides some great APIs for doing this. It means you don't have to do multi-tenancy within the service or the network service that you're delivering. It means it's all done at the network level. VPCs offer a number of kind of very interesting connectivity options. One of the ones that I haven't explored in this slide deck is actually AWS Direct Connect, which allows you to connect to one of their supported private data centers like Equinix and Layer 3 and all that fun stuff. You can also use Direct Connect to do VPC peering across different AWS regions within the continental US. We haven't done anything around that space, but we'd be excited to try if the requirement came up. The other thing as well is that to do some of this stuff, particularly the public IP address space, is to ensure that your service supports robust authentication. At the end of the day, even if you're not doing it, your service should support robust authentication, but it does make your life a little bit easier in other areas. Multi-tenancy, it does allow custom connectivity and functionality without impacting your other customers. And you can also extend that to doing, rolling out other versions earlier and all that kind of fun stuff, but you've got that true network isolation. So it does mean that if you do something a little bit early, it's only going to impact that one customer where you've decided to roll it out to, or they've requested access to beta functionality or that kind of thing. So it's been a rather short talk. Thanks, guys, for kind of coming out after the replay party. And I'd like to open the floor to any questions.